All right, so today we are going to do dynamics. In dynamics, you learn a lot about forces, vectors, moments. Also, you learn a lot about the momentum, energy, and work done. So all of that stuff you learn in this class. So let's start with the with vectors first. We did vectors in the very first class, so I'll not focus on vectors a lot. I'll just tell you the basics you need to know for this chapter. So yeah, so remember that scalar quantities only have scalar quantities. Yeah, scalar quantities only have a unit or a quantity, whereas quantity, whereas vectors have quantity or magnitude as well as a direction. And remember that the vectors you need to know are uh, the main vectors are forces, momentum, and and you learned that later on as well. So let's start with Newton's law first. Newton's first law, or the law of inertia, states that an object continues it continues its state of rest or uniform motion unless an external force acts on it. Inertia is the property of a body which resists a change in state or motion or rest of body. So if Newton's first law, basically it states that if a car is moving at uniform speed, at let's say speed A, then it will keep moving on this speed unless there is an external force that acts on this car. If there is an external force, maybe resistance, then the car will slow down or eventually stop. So this is the first law. And inertia is the property of body which resists a change in state of motion or rest of body. And remember that inertia depends on two things: the mass of the object and the speed of the object. So two things, remember these. And so inertia is proportional to mass. If there is more mass, then you'll have more inertia. And similarly, inertia is directly proportional to speed as well. If you have more speed, if this car is moving at a faster speed, then there will be greater inertia. And if this car was to be heavy, then there would be greater inertia as well. So momentum, right, we all know, is product of mass and velocity. So momentum is mass into velocity. And you also have to know the SI base unit of this. I told you how to figure that out because mass we know has an SI base unit of kg. And velocity, remember, it's ms negative 1. How did I find this? I know velocity is distance into time. So distance is the unit of distance is meter. And sorry, uh, this velocity, my bad, velocity is distance over time, not distance into speed. What am I saying? Distance is meters, time is measured in seconds. So this goes up, becomes s negative 1. So you have to know, you have to memorize this SI base unit of momentum, as well as for all of the forces and all of everything I'll talk about. You have to memorize the SI base units. So moving on, remember that change in momentum is mv minus mu. Why is this negative? I've seen questions where they ask why the change in momentum is negative or positive. That depends on the final motion of the body. So let's say that this ball, which has a mass of 500 grams, moves towards a wall that is 20. This ball is moving at a speed of 20 meters per second, and it hits the ball. It hits the wall, and then it moves in the opposite direction. At what speed? At 15 meters per second. 15 meters per second is the final velocity. And the initial velocity of the ball is 20 meters per second. So they are asking me, how do you find change in momentum? I know change in momentum is mv minus mu. So remember, mass is mass is 500 grams. 500. Remember, mass is always calculated in kgs because the SI base unit of momentum involves kg. So you'll convert this into kgs by dividing by 1000, or you can simply divide this by 10 raised to power 3. And the final velocity, I know, is in the opposite direction. So I'll multiply this by 15 because that's the velocity, the final velocity. This is V is refers to the final velocity minus uh U, which is the initial velocity, which is 20 into the mass, which is 500 over 1000. Now there is one problem here though, that it's that momentum. Remember, I told you momentum is a vector quantity. So momentum will have direction as well. What do I mean by direction? If a ball is moving in the right direction, then the momentum of this ball would be positive. If it was to go in the left direction, the momentum would be negative. Similarly, if this ball was to go up, then the momentum of this ball would be positive. And if it was going down, then the momentum of this ball would be negative. So in this case, I have to consider the directions as well. And always, this is the main point that they'll ask questions regarding. They'll give you the directions, and you have to figure the signs of the momentum or forces. So in this case, uh, my velocity is vector. So I have to consider my direction, the right direction, as positive, and my left direction as negative. So with this negative, right, I'll also multiply with another negative, in this case, in mu, because remember, my u or my initial speed is towards the right. My initial speed is towards right. My final speed is in the left direction. So I'll take negative, this as negative. Therefore, uh, my final velocity is this, right? My final velocity was in the left direction. So I'll take this as negative. This velocity would be negative. So I multiply this 500 divided by 100 times negative 15 minus, because this minus comes from the formula, minus 20 times 500 over 1000. So solve this, and I get my final change in momentum as negative 17.5. So yeah, notes that you have to take here, that right direction is positive, left direction is negative. And remember, why is momentum a vector quantity? Because in the formula of momentum, momentum's formula is mass into velocity. Velocity right here has direction. So you'll always consider directions when dealing with momentum. Yeah. So let's move on to forces now. So any force in the direction of acceleration is called the forward force. So if I have a if I have a car that is moving this way, then the acceleration is towards the right. So my force is, if it's pointing towards the right, if my force is pointing towards the right, that force will be known as the forward force. But if I had a resistive force, say there was resistance between the tires and there was a backward force, then this force would be my resistive forces. And remember that if I have, when there is more than one force, when I have two or more forces, then I use this formula. This formula states that F minus F equals MA, where this minus F is the resistive force. And this F is the forward force. Yeah. So if force is in direction of acceleration, we write it as positive. And if it is in the opposite direction, we write it as negative. So remember, I told you forces have direction as well. So if in this case, the resistive force would be negative, my forward force, it's in the right direction, would be positive. And remember, tension in a rope is always pointed away from the object. We did this concept in the last class as well. So what do I mean by this? If there was a ball that was hanging from a wall, then the tension, right? The tension in this rope would be away from the object. So in this case, it would be pointing upwards. And so let's do a question now. A box of mass 8 kgs rests on a horizontal rough surface. A string attached to the box passes over a smooth pulley and supports a 2 kg mass at its other end. When this box is released, a frictional force of 6 Newton acts on it. What is the acceleration of the box? This is a very this is the type of question they'll ask you in physics because there is not a lot of confusing numbers to deal with. So yeah, I think you have enough knowledge now to solve this question. But yeah, so solve this question. I'll hide the answer. I'll give you 2 minutes to find the answer. All right. So they're asking me to find the acceleration of the box, and they've given me the forces as well. So I can use, because I know there are more than one forces, there is two or more forces, then I'm going to use F minus F equals MA, where all of this is depending on my box. For example, here, my this negative F would be my resistive force. So how do I solve this? First step, I'll write the formula. F minus F equals MA. Uh, can you guys stop your video? All right. How do I stop this? Yeah. F minus F equals MA. The forward force, this right here, would be mass into acceleration. What's the forward force here? The forward force is the force due to my weight, because this rope will move downwards because of this mass right here, and this would cause the box to move forward. And my acceleration, they've given me in the diagram, it's towards this, it's towards the right. So in this case, my forward force would be the force due to this box right here. So the acceleration of this box, I know it's 9.81 because that's the acceleration due to gravity. So 9.81 into the mass of this object, which is 2 kgs, and that will give me the weight of this box or the force of the box. So minus the resistive forces. So what are the different resistive forces I have on this box, acting on this box? So first of all, there would be tension. Definitely there would be tension in the box. And you can see that this rope is attached to this box right here. So my tension would oppose this box. So if it's moving this way, the box is pointed this way, the tension would point away from the box towards here. And similarly, my tension would be also present right here. When I have this box connected, this tension would point away from the box, so this way right here. And remember that tension for this big box is pointing away from the object, and it's at the positive side. So it's at the right side. And this force, this tension, is considered as the forward force as well. Because remember, I told you that whatever force is acting in the direction of acceleration, it's considered as the forward force. So minus F in this case would be my tension in this rope right here, in the tension due to this 2 kg box, plus the tension due to my box, the 8 kg box, because remember, that's the forward force. So plus T minus F is the resistive force right here, which there would be some resistive force because they told me that, hey, the rest on a horizontal rough surface. They told me it's a rough surface. So remember, when our question says there is the surface is rough, we'll consider that there is some resistive force, or we can call this friction as well. So there will always be friction when they tell me the surface is rough. And this friction, remember, it's in the left direction. So I'll take it as negative. So I'll write it as negative F. This is the friction in the opposite direction. So uh, this equals MA. What is the M here? The M is the mass of the box, which is 8. But there is also the mass of this small box to consider. So I'll take 2 as well, multiply with the acceleration that I need to find, the forward acceleration. And now I can simply use my algebra and solve this. And I can obviously cancel negative T plus T out because these are opposite in sign, so I can cancel these out. And remember, this is a very important concept, that if I had a wall that had rope attached to this ball, and then there was another ball attached to the same rope. In this case, my tension, right, which should point away from the balls, this tension in one rope, remember, tension in a continuous rope is constant. So my tension, wherever it is, be it here, here, or here, it would be the same. So in this case, my tension is in this rope, the tension is the same. So I can cancel these values out. And when I solve this equation right here, I'll get my acceleration as 1.45. So yeah, this is the type of questions they can ask you. We have a question at the end from the IMAT. We'll do that as well. So what's Newton's third law? Newton's third law states that every force or every reaction has an equal or opposite reaction. This is Newton's third law. There are 4 conditions for Newton's third law. That the first one is that the force must be equal and opposite. The force that is the opposing force, this must be equal and opposite. And the second rule is that the forces must be of the same type. What do I mean by forces of the same type? For example, in this case, here, when I have 2 magnets coming close together, they'll oppose each other. This would be due to the magnetic force. So when I have magnetic force opposing each other, you can see both of these are magnetic forces. So Newton's third law can be applied here. But if this force was not the same, if one of the forces were not the same, then we can't consider the Newton's third law to be applied here. So yeah, the third rule is that let me just move to one. Yeah, if you have a question, you can raise your hand. The third rule is that the forces must be acting on 2 different objects. I'll explain this using this example, but the fourth and the last rule is that the force must act on each other on the same time. So let me take this example. A man is standing on the earth right here. So the force of gravitational pull pulls you downward from the earth. You can see that there will always be weight that will be pointing towards the earth. This would be the downward force. And there would be force of attraction upwards from the man. The force of attraction upwards from the man, this is known as the normal force. And remember that whenever you have 2 objects that are in contact, let's say that I had a surface, there was a box on this surface, then when two objects are in contact, there will always be a normal or a contact force. This is called the normal or the contact force, and it will always point upwards 90 degrees, and it would always point upwards to the surface. For example, here, my contact force will be pointing this way. And similarly, this is known as the contact force. So let's say this is C, and the downward force would be the force due to weight, which will act downwards. And in this case, right, in this example, my weight is a gravitational force. My weight is a gravitational force, but my contact force is not a gravitational force. This contact force is not considered as a gravitational force. So in this case, I will not consider these two forces as Newton's third law. This is not Newton's third law. All right. So yeah, this is the Newton's third law, and this is moving on to moments now. Moment is very important. They'll ask you what they'll give you questions. Usually they'll give you questions. This moment questions would be very simple. So what is moment? Moment is the product of force applied and perpendicular distance from the pivot. So if I had a bar and there was this pivot right here, then there would be a force, and if it moves clockwise, then there would be a moment. And the formula for moment is, remember, force times distance, and the distance is from the pivot to the force that is acting on the bar. And remember that this distance would always be the perpendicular distance. What do I mean by perpendicular distance? Perpendicular distance basically means that the distance would always be considered if the force is upwards or downwards. In this case, my distance is this right here, from the pivot to the force, the perpendicular force. And you can see that the angle between the force and my distance is 90 degrees. So you'll always consider the perpendicular forces, perpendicular distance when you're dealing with moments. But so I want to talk about equilibrium. Equilibrium is when the state of body when acceleration is zero. And there are two conditions for equilibrium. Then the first one is that the sum of forces acting on the body must equal to zero. What do I mean by this? If I had a bar that had a pivot right at the center, and if it was stationary, if it's not moving at all, then my sum, the total sum of my forces would equal to zero. This means that the total upward force equals the total downward force, because my object is not moving at all. So the force that is pushing it upwards, it must be equal to the force that is pushing it downwards as well. So remember, when you are in equilibrium, then the resultant force will equal to zero. And remember, the second rule for equilibrium is that the sum of moments acting on the body must be equal to zero. This means that the object must not be spinning. This basically means that if I had a bar and there was a pivot, then if it was in equilibrium, meaning it is not moving at all, it is not spinning, when it's at the equilibrium, I will say that my clockwise moment is equal to my anti-clockwise moment. My anti-clockwise moment is this way. So this anti-clockwise moment is equal to the clockwise moment. So clockwise moment. Whenever I am in equilibrium, my anti-clockwise moment equals my clockwise moment. This basically means that if I had a force in this direction and I had a force in this direction as well, then the product of this force into the distance must equal the force into the distance of my anti-clockwise moment. So force into distance, this is my anti-clockwise moment, and this is my clockwise moment. So yeah, other than that, other than moment, whenever you have equilibrium, remember, whenever you have equilibrium, then the object would either be stationary, or this is the first case, or it would be traveling at constant speed. This is the two moments that you'll have equilibrium. So yeah, so there is a concept called couple in moments. This says that when do you have a couple? When the distance, when you have equal forces acting on an object, you'll have a couple. So for example, if I had a force this way, let's say this force was 5 newtons, and I had a force acting downwards, this was 5 newton as well, then this would be a couple. And what is the formula for finding couple? It's force into 2 times the distance. What is the distance? The distance is from the center of the pivot, from the pivot to the force. And this distance, remember, it's perpendicular. So I'll multiply this by 2 because I have this distance as well for the second force. So remember, couple is force into 2 times the distance. Uh, there was a question. I want to solve that first. This one. Yeah. This is from IMAT 2014, I think. 2014 or 15. I'm not sure. If you can solve this, then you've understood everything for moment and forces. So yeah, you have around 3 minutes to solve this question, and then I'll solve it myself. All right. So the diagram shows a uniform horizontal beam of negligible mass, 5 meters long, placed on 2 support, each at one at each end. It has a 300 Newton weight placed 1 meter away from one end. So 300 Newton at one end. And from the other end, there is a 500 Newton force that is placed 1 meter from the other end. Both weight act vertically on the beam as shown in the diagram. What are the upward forces from the two supports acting on the beam? So if you've solved this question, great. And if not, then I'll record the answer for this question and I'll send it on the Discord server because we only have 10 minutes left and we have to do a couple of more things. So I'll send the answer of that, but moving on to work done. Work done is the product of force applied and the distance moved in the direction of that force. Sarah is saying A. I'll find the answer. I'll do it myself and then record the working of this answer. So work done is the product of force into the distance in the direction of that force. That force and the distance must be parallel. So this can also apply to force in opposite direction to the distance. So remember, the one rule for work done is that the force must be parallel to the direction. So if I had a car that was moving left then the work done for this would be distance into my force. But if my object was moving towards the right, then I'll do distance into negative f. Or I could say that this side is negative, and I'll consider this as negative and then this as positive. So remember, distance times force, and remember force have direction as well. Uh, there is one another rule I have to talk about. That's if this object was moving in this direction, but the force was acting upwards, then I will not call this work done. I cannot use force into distance because this force is perpendicular to the direction, which is in this way. So yeah, uh, so the unit for work done is joules, and remember, joules is kg ms negative negative 2. Kg ms negative 2 is for force, and distance, remember, it's m. So the SI base unit for work done is kg m2 s negative 2. So yeah, uh, work done by a gas. The formula for work done by a gas is pressure into the change in volume of that gas. If you don't move, then you have zero work, since work equals force into distance. And if you don't move at all, if the distance moved is zero, then the work done is also zero. And yeah, energy is the ability to do work. Kinetic energy is the energy possessed by a mass due to its virtue of its motion. And similarly, the formula is half into mv square. And potential energy is the ability to do work, or in another way, the definition of potential energy is the energy due to the virtue of its height. And the formula for potential energy, remember, it's mgh, where m is mass, g is 9.81, and h is the distance from the base or the ground. Yeah. So moving on to power, finally. Power is the rate of doing work. Rate means something, some value divided by time. So rate of doing work, this would simply mean work done over time taken. And I can replace work done with energy as well, because energy and work done both have the same SI base unit. So the formula for power can be energy over time as well. And this, remember, this energy can be kinetic energy, potential energy, any type of energy. And power has another formula as well. Power is force. Remember, power is force times velocity as well. Why? Because power is work done over time. I know that work done is force into distance over time. This distance over time, right? This distance over time equals to velocity. So I can use another formula. Power is force into velocity. And finally, efficiency. Remember, efficiency is the formula for efficiency is output power over input power into 100%, or simply 100. You don't have to write this percent. Remember that if I had this system, then the input power would be the power that is supplied to the system, and the output power is the power that you will receive from the system. So the output power is the power that is given out due to the system. And remember that input input power will never equal to the output power. You'll always have some power loss. This power loss can be due to heat energy, it can be due to noise. It can be due to kinetic energy, due to many different ways. So remember, input power will never equal output power. So what is the formula for input power? Power input, remember, will equal to the power output, the output power, plus the power that is lost to the surroundings. So yeah, this power lost due to the surrounding plus the output power will give you the input power. Yeah. So I think we have some time. I can solve this question as well. So first of all, we have to know this important rule that when you have a pivot at a force, you can cancel that force. For example, in this case, I can put my pivot anywhere. Remember, you can always put your pivot anywhere and then solve for moments. So for example, if I put my pivot here, then this force right here would be cancelled. And similarly, if the pivot was here, I put my pivot here, then this force, the upward force, would be cancelled. They tell me that what are the two upward forces that support the beam? They are telling me that the beam is stationary, it's not moving at all. That means if there would be upward forces due to these pivots. So if I consider this pivot right here, let's say I take this pivot right here, then what would be my moment? My moment, remember, they're telling me this is stationary. So my clockwise moment equals my anti-clockwise moment. This will, remember, I'll always use this formula when my object is stationary, it's not moving at all. So I'll say clockwise moment equal anti-clockwise moment. The clockwise moment is this way right here. Sorry, uh this way right here, when the bar moves this way. So that would be this force right here, the upward force. The upward force is x, I don't know, and then multiply this by the distance from this force till the pivot is 5 meters, because they told me the bar is 5 meter long. So x into 5, this is my clockwise moment. This is the first clockwise moment. This is equal to my anti-clockwise moment. My anti-clockwise moment is in this direction. So that would be 500 times the distance from the pivot, which is 1. So no need to write 1 because 500 times 1 is 1. Plus this is one moment. The other anti-clockwise moment is due to this force right here. So plus 300 times the distance from this force, which is 4 newtons, 4 meters. So 300 times 4 meters. And I get my x as, wait,